Hello and welcome to another Grade Gain Required Practical. This one is for GCSE Physics, it's Required Practical 9 and it is all about light. What we're going to do today is we're going to be using the instructions that are downloadable from my web shop. Web address is appearing here. And we're going to follow these instructions and we're going to be looking at refraction and reflection of light through different materials. In order to do this, you're going to need a ray box. Now with that ray box, you're going to need a power supply. You're going to need two different material blocks. Here we've got a glass block and a perspex block. You're going to need a protractor and a ruler. But most importantly, you're going to need a sharp pencil, because with a nice fine line, we can get some really accurate readings. So here we have the power supply on 12 volts connected up to our ray box, which is shining a ray of light out onto our white paper. Here's our single slit. We're going to put it with this end into the ray box, and that gives us a lovely fine line that we can now work with. So we set our glass block on our paper and we draw around it using our sharp pencil so that we know exactly where our block goes if we need to move it. For the next bit, we need to have darkened the room, which I've managed to do. We turn our power supply on and we get our lovely ray of light coming from the ray box. Now if we look carefully, we can see that we've got the ray of light coming here to the block. There is a very faint reflected line here, and then the ray of light emerges from the ray box over here. In order to draw this diagram, what we've got to do is we place an X with the middle of the X in the middle of the ray of light, showing where the light is coming from. We place a dot in the middle of the ray of light where it incidents on the glass block. We place an X on our faint refracted ray. We place a dot where it leaves the block here, and we place a cross a little further away here. We now have all of the information that we need to draw our ray diagram. So we turn our ray box off because it's going to get hot and we don't want to burn ourselves. Now we remove the ray box and our glass block, and we can see we have all of the points that we need. So using our ruler, we're going to draw a line from the middle of the X to the dot, from the dot to our other dot, and from our dot to our X, and that's the path of our refracted ray. Now our reflected ray comes from the dot here to the cross there. We need to place arrowheads on to show the direction that the rays of light are taking. Now we need to put our normal in. The normal is a line that goes at the point of incidence at 90 degrees to the boundary. Now to make sure we get it at 90 degrees, we're going to use our protractor. We'll place the crosshairs of the protractor onto our dot, and then we make sure that our lines line up along here, and we put a dot at 90 degrees. We now have two reference points, this dot and the point of incidence, so we can join those up. Now this is a construction line. So because it's a construction line, it's a dashed line. So now we can measure our angle of incidence, our angle of reflection, and our angle of refraction. To do this, again, we place the protractor crosshairs on the point, the zero line going up and down the normal, and we can now measure off, reading round from here to here, which gives us an angle of, there's 45, 46, 47.5 degrees. Turn our protractor 180 degrees, and we can measure now the angle of reflection, 45, 46, 47.5 degrees. Notice I used the outside scale when it was this way round, and the inside scale when it was this way round. We now want to measure our angle of refraction. There's 25, 26, 27, 28 degrees. We now have all the data for this block, making sure we make a note that that was glass, and we can do the same again for our perspex block. Now you will notice that before I start here, I've drawn around my perspex block, I've put a normal in, and I've got an X here. This X represents an angle of 47.5 degrees from the normal, because I want my ray of light to be coming in at the same angle. So that is one of my control variables. I've drawn around my block so I can make sure I place it in exactly the same place. Turn my ray box on, and then I shine it so that it's incidenting via the X at the point that I've chosen to incident on my perspex block. Now if we look very carefully, we can just about make out our ray that has been reflected. So we put an X where that is coming through. Again, we place our dot where it's leaving the block, and an X, so the middle of the X is in the center of the ray. Now we remove all of the equipment, and we have our dot to dot again. So we join up the center of that X with the point of incidence to the other dot, the center of the X, and our reflected ray from the X to the point of incidence. Put our arrowheads on to show the direction that the ray is taking, and record that this is our perspex block. Now, using our protractor again, place it on there, and we can see clearly that we've got 47.5 degrees, 45, 46, 47.5 degrees. Spin it round, want to measure our angle of reflection, 45, 46, 47.5 degrees. Measure our angle of refraction. Here we can see that it's 25, 26, 27, 28.5 degrees. So here's our results table. Our angle of incidence for both blocks was 47.5 degrees, because remember we controlled that. Reflection for our glass was 47.5. Refraction was 28. Reflection for perspex was 47.5, but refraction was 28.5 for the second block. So we can see that the angle of incidence is always equal to the angle of reflection. So I, the angle of incidence, is always equal to R, the angle of reflection. But we get a different amount of refraction depending upon the material that we're using. So there we have it. Our angle of incidence is always equal to the angle of reflection, as shown here, and we know that the angle of refraction changes with different materials. Remember, angle of incidence equals angle of reflection. That's one of our basic rules in physics. In the exam, you may be required to recall how to write that method. Remember, keep it simple. Bullet points. Step 1, step 2, and so on. Hope you found this a really useful video, and don't forget you can subscribe to my channel, Grade Game, here. Watch some of the other required practical videos here, or some of my other adventures right here. Okay, keep watching and good luck in your GCSEs.